So, what's up guys? Info here. We talk a lot on this channel about the latest and greatest tech, the fastest processors, the brightest displays, the slickest designs. But there's one component, one piece of the puzzle, that literally powers everything we use, and we almost never give it a second thought until it runs out. I'm talking about the battery. It's the unsung hero inside your phone, your laptop, your camera, even your car. But not all batteries are created equal. The magic, or the science really, is in the chemistry inside, and that's what we're diving into today. Today we're breaking down the pros and cons of the most common battery chemistries. It might sound a little nerdy, and okay it is, but stick with me here. Understanding the difference between, say, a lithium-ion battery in your phone and a lead-acid battery in your car is actually super important. It explains why some devices are lighter, why some last longer, why some are more expensive, and why some have certain safety considerations. This isn't just an abstract science lesson. It's about understanding the core technology that dictates the performance and limitations of the gadgets you use every single day. Knowing this stuff helps you make smarter buying decisions and appreciate the incredible engineering that goes into making our tech world go round. So, let's get into it. Let's talk batteries. Alright, first up, we have to talk about the king, the one you're probably most familiar with, lithium-ion, or Li-ion. This is the chemistry that powers the vast majority of your portable electronics. Your smartphone, your laptop, your wireless earbuds, your drone. Pretty much anything that needs a lot of power in a small, lightweight package is running on Li-ion. The biggest reason for its dominance is its incredible energy density. That just means it can pack a whole lot of juice into a very small and light form factor, which is obviously a huge win for devices we carry around all day. Plus, they don't suffer from the memory effect we'll talk about later, and they have a relatively low self-discharge rate, so they hold their charge well when not in use. But, it's not a perfect technology. For one, lithium-ion batteries are more expensive to produce compared to some of the older chemistries. The materials are pricier, and the manufacturing process is more complex. And then there's the big one, safety. We've all seen the headlines about phones or hoverboards catching fire. While rare, Li-ion batteries have a volatile electrolyte, and if they're damaged, overcharged, or have a manufacturing defect, they can enter a state called thermal runaway. This can lead to overheating and, in worst-case scenarios, fire. It's a trade-off we've implicitly accepted for that high performance and portability. Next up is a chemistry that was the heir apparent before lithium-ion took over the world, nickel metal hydride, or NiMH. You'll still find these everywhere, especially in the form of rechargeable AA and AAA batteries. If you have a battery charger for your TV remote or your kids' toys, you're likely using NiMH. One of their biggest selling points, especially when they first came out, was that they were a more environmentally friendly alternative to the older nickel-cadmium batteries, since they don't contain toxic heavy metals like cadmium. They offer a decent energy density, not quite on the level of Li-ion, but a solid step up from their predecessors. The main drawbacks for NiMH, and the reason they're not in your smartphone, are their lower energy density and voltage compared to lithium-ion. You'd need a much larger and heavier NiMH battery to power a modern phone for a full day. They also have a higher self-discharge rate, meaning they lose their charge more quickly when just sitting on a shelf. You might charge them up, put them in a drawer, and find they're half empty a month later, which can be frustrating. They can also be a bit more sensitive to overcharging and high temperatures, which can degrade their lifespan over time, so using a smart charger is always a good idea. Now let's talk about the oldest, and in some ways, the most dependable battery technology on our list, lead-acid. If you've ever had to jumpstart a car, you've interacted with a lead-acid battery. These have been around for over 150 years, and there's a good reason they're still here. They are incredibly reliable, robust, and cheap to manufacture. Their ability to supply a huge surge of current is what makes them perfect for starting a car engine. That massive cranking power is something other chemistries struggle to deliver so cost-effectively. They're also very tolerant of overcharging and are generally quite safe under normal operating conditions. But the downsides are pretty obvious the second you try to pick one up. Lead-acid batteries are incredibly heavy and bulky. That's due to the lead plates and the liquid electrolyte inside. Their energy density is, by a huge margin, the lowest of all the types we're discussing today. This makes them completely impractical for any portable electronics. Imagine trying to strap a car battery to your back just to power your laptop for a few hours. It's just not happening. They also contain lead and sulfuric acid, which are hazardous materials that require very specific and careful recycling processes to avoid serious environmental contamination. Let's turn the clock back a bit to a technology that was a staple for power tools and early cordless phones, nickel-cadmium, or NiCd. The defining characteristic of NiCd batteries is their toughness. They are absolute tanks. They can handle a ton of abuse, operate in extreme temperatures, both hot and cold, where other batteries would just give up, and they can be charged and discharged thousands of times. This durability and ability to deliver high power output consistently made them the go-to choice for demanding applications like cordless drills, which need a lot of torque on demand. They also have a very long shelf life. However, NiCd batteries have some major drawbacks that have led to them being phased out in most consumer products. The first is the infamous memory effect. If you repeatedly recharge a NiCd battery before it's fully drained, it can forget its full capacity and will only hold the charge from the point it was recharged. It's a real pain to deal with. But the even bigger issue is their environmental impact. Cadmium is a highly toxic heavy metal, and improper disposal of NiCd batteries can lead to serious soil and water contamination. This toxicity is the primary reason they've been largely replaced by NiMH and Li-ion in most applications. Finally, let's talk about what might be the next big leap. The holy grail of battery tech that everyone is chasing, solid-state batteries. As the name implies, these batteries replace the liquid or gel electrolyte found in current Li-ion batteries with a solid material, like a ceramic or a polymer. This single change has the potential to solve some of the biggest problems with today's batteries. First and foremost is safety. By removing the flammable liquid electrolyte, the risk of thermal runaway and fires is dramatically reduced. That is a massive, game-changing improvement right there. Beyond safety, solid-state technology promises even higher energy density than the best Li-ion batteries we have today. This could mean phones that last for days, or electric cars with over 1,000 miles of range, all without increasing the size or weight of the battery pack. So, what's the catch? Well, right now, the catch is everything else. They are incredibly difficult and expensive to manufacture at scale. The solid electrolytes can be brittle, and maintaining a good connection between the electrodes and the electrolyte over many charge cycles is a huge engineering hurdle. So while we're seeing them in a few very small specialized devices, widespread commercial availability in our phones and cars is still likely years away. But it's definitely the future everyone is watching. So there you have it, a tour through the world of battery chemistry. From the heavy and reliable lead acid in your car, to the lightweight and powerful lithium-ion in your pocket, and even a glimpse at the promising solid-state batteries of the future. It's clear that the choice of battery is a complex balancing act. Engineers have to weigh energy density, cost, safety, lifespan, and environmental impact to pick the right tool for the job. There's no single best battery, just the best battery for a specific application. Each battery chemistry has its strengths and weaknesses, so the best choice depends on your needs. The reason your phone uses Li-ion is because you value portability and long life above all else, and you're willing to accept the cost and minor safety risk. The reason your car uses lead acid is because it needs massive starting power, and cost and weight are less of a concern for a vehicle. Understanding these trade-offs gives you a whole new appreciation for the tech you use. Now I'm curious to hear from you guys. Take a look at the gadgets around you. Which battery type do you think you use the most in your daily life? Is it mostly lithium-ion from your phone and laptop? Or maybe you're a power user with a bunch of NiMH rechargeable batteries for your camera gear and controllers? Drop a comment down below and let me know. It'll be interesting to see the breakdown. Thanks for watching, and I'll catch you in the next one.